What is the purpose of a router? Routers are going to allow us to break up one large local area network into multiple smaller local area networks. So always think about this. Your router is really defining different local area networks with its interfaces, essentially allowing us to have different subnets. So every interface is going to be part of a different subnet, a different network, a different LAN, a different broadcast domain. So if you want to focus on the term broadcast domain, there's one broadcast domain. There's another broadcast domain. How many collision domains do we have, though, here? Oh, wait a second. Yeah, there's a term that would have crept up in a discussion on switches. Well, here's one collision domain. Here's another collision domain. Here's another collision domain. And here's another collision domain. So remember, every single port on a switch is in its own collision domain. And every router interface is defining a broadcast domain, local area network, subnet. All of those terms are used interchangeably there. So collision domain is created by the switches, and the broadcast domain is created by the routers. So what is a router going to do now? A router is going to have to learn where all the different networks are. So in this particular case, you can see that the router knows about two different networks, 192.168.1.0/24 and 192.168.2.0/24. And the 1.0 network's out fast Ethernet 0/0, and the 2.0 network's out fast Ethernet 0/1. All right, so think about this for a second. What are these right here? What are those? Go back to a discussion on subnetting and IP addressing. What are those? Those are network IDs. That's right. So the router is going to use network IDs and place them in a routing table, associate them with interfaces that can be used to reach them. So that way there, when it receives a packet, it can look at the destination IP address in the packet, compare it to entries in the routing table, and ultimately determine where that packet has to go. So look at this example here. We have two different LAN, local area network segments, two different broadcast domains here. One of them is the 10.18.00/24 network, and the other one is the 10.22.00/24 network. We have multiple collision domains. 1, 2, 3, 4, 5, 6, 7, 8 different collision domains. 2 different broadcast domains in this example. So what's going to occur here when PCA in LAN A wants to talk to PCC in LAN A? Nothing special. Just the fact that it needs the MAC address of itself as the source, the MAC address as PCC as the destination, and then the frame goes from here to here. It's pretty simple. So when does the router get involved? The router gets involved when we want to communicate from one local area network to another local area network. So let's say PCA over here wants to talk all the way over here to PCB. So how is that going to function? How is that going to work in this particular case? Well, PCA sends now the information to the router. Once the router receives that information, the router says, how do I get to PCB? Now, is the router making its decision based on frames here? No, it's making its decision based on packets at layer 3 of the OSI model, or the internet layer of the TCP/IP stack. So PCA has an IP address of 10.18.0.0.5, let's say. PCB has an address of 10.22.0.5. So what happens here is that PCA says, all right, I have a packet to send to 10.22.0.5. That is our PC here of PCB. So it has .5 as its address. So the router receives that and says, okay, I just received a packet that's destined for 10.22.0.5. Do I have a network in my routing table that will help me reach that particular device? And the router says, yeah, I do. Actually, I'm directly connected to 10.22.0.0. So I'm going to send the packet out over to that PC. So the router is responsible for connecting those different local area networks together. The different local area networks could be all over the place. They could be all directly connected to the same router, or they could be all over the world. So routers are positioned all over the world, inside your networks, outside your networks, on the internet, in ISPs. So that way there you have the ability at any point in time to type in www.cisco.com and your packet leaves your PC and goes where? To www.cisco.com through many different routers.